Okay, so what I see when everybody does this is, there are a few mistakes. And let's start with -2 here. Most people either got 4 or -4, okay? If you square -2, that means -2 times -2, right? And if you multiply two negatives, you get a positive, right? So this has to be 4. Okay. And I'll write a little note out here, -2 squared means -2 times -2, which equals +4, okay? And then if you square -1, well, that's -1 times -1, going to give you a +1, so you get 1. Now we get the fractions. Okay, so -1/2. It's -1/2 times -1/2. 1. -1/2. Well, 1/2 plus 1/2 is 1, right? If you have 1 there, okay? But we're not adding, we're multiplying, okay? And you've got to multiply the fractions. That means you have -1. Well, let's do it like this. I'm just gonna gloss it over. We have a product of two negatives, so it's gonna be positive. Going to be the same as 1/2 times 1/2. And 1/2 times 1/2 means you multiply the numerator, 1 times 1. And you multiply the denominators, 2 times 2. Now you multiply fractions. Okay. And that gives you 1/4. So for this one, we're going to get 1/4. Okay. Now 0 times 0, that's 0. 1/2 times 1/2, well, that's going to be 1/4. It's just like -1/2 times -1/2. Except we don't have those negatives, we don't have to worry about that. Okay, so that's 1/4. And of course, 1 times 1 is 1, and 2 times 2 is 4. Okay. Now, this is maybe the most important or the easiest to understand basic function. This is called the basic squaring function, or the toolkit. I should have checked, see who's teaching the section, but I think it's Mr. Lockney. He uses my open math for the course, and we're using it here. Okay. So you're going to see a lot of similar stuff, not the same stuff, but similar stuff. Okay. And toolkit is the terminology we use for about a dozen standard functions. Okay. And these functions are used to build almost all the other functions you study in undergraduate school. Unless you're a math major, you go a little beyond, okay? If you're an engineer, okay, you're a chemist, you're a physicist, now physicists will go beyond it too. So will some chemists. But the point is, almost all the functions that get used in science and business, just all over the place, are built on a dozen functions, and really there are about 5 of them that cover 90% of it. Okay. Okay, so we have the toolkit squaring function. Again, that's f of x equals x squared. Now, why do we say f of x? Well, it's a shorthand way of referring to a function. Okay. We don't want to say every time we talk about it, we only say the toolkit squaring function. We just say, okay, f of x equals x squared. F of x is the toolkit squaring function. So now we just talk about f of x. Okay. The other part of it is it tells us how to calculate the result. Okay, so here we have, okay. F of x equals x squared. So what is f of 7? Okay, I'm going to give you a chance to take a stab as well as I'm. Okay, okay, yeah. Okay, so we got an answer. Somebody said 49. Most people say, yeah, that sounds right. Because what? 7 has replaced x here. Well, if you replace x one place, you're going to have to replace it in the other place, right? So it's just a matter of substitution. We substituted 7 for x. So we're going to say, well, then that has to be what we get. We substitute 7 for x over here. Is that a big surprise? I doubt it, because we got the right answer right away. Maybe everybody did. Okay. F of 7 is 7 squared, which is 49. F of -3 is -3 squared. Now I'm going to write that out carefully. It's the quantity -3 squared. If I wrote -3 squared without the parentheses around it, then only the 3 would get squared, the negative wouldn't, because of the order of operations. The square only applies what's immediately to its left. And if there's a negative sign to the left of the number, and the square is on the number without the parentheses, then you're not squaring the negative. Okay. So you wouldn't have -3 times -3. Well, think about that a little bit, but in any case, in a function notation, this is clearly then 9. Okay. Now, what can we do with this? Well, we can make a graph. And we can take these points. We can take the numbers on this table and represent it on a graph with y versus x. And so x values go from -2 to 2. And y values go from 0 to 4, right? I'm going to set my axes up this way. And we have -2 here. Where's -1? Well, it's halfway between -2 and 0. Here's -1. Halfway between 1 and 2, we have 1. Halfway between 0 and 4 is 2. Halfway between 0 and 2 is 1. Halfway between 1 and 2 is 3. And then if we cut the interval from 0 to 1 in half, we get a half, right? And then we cut that in half and we get a fourth. And we're going to need a fourth because we got a fourth. Well, now we have our points. When x is -2, y is 4. Now x is -2 everywhere on this vertical line. Okay. And y is 4 everywhere on this horizontal line. So this is a line where y equals 4. This is the line where x equals -2. So this is a point where x equals -2 and y equals 4. And we could even label the point, we could label the coordinates. -2, 4. Wrote that kind of small, can't see it back there, it just says -2, 4. Okay, I'll write some of the others a little bigger. If I could go ahead and do the y equals 4. Or x equals 2, y equals 4. Okay, so we got this point on the graph. Okay. Now, let's go to bottom all. Let's just skip to 0, 0. That was easy, right? X is 0. Here, everywhere on this vertical line. That's important. X is 0 everywhere on the y-axis. Y is 0 everywhere on the x-axis. So we've got the point where x equals 0 and y equals 0. That's the point 0, 0. And over here, we've got the line where x equals 4, x equals 2. So we see where the line where x equals 2 meets the line where y equals 4, and this is the point where x equals 2 and y equals 4. That's the point we call 2, 4. Okay, now we've got -1, 1. -1, 1. Now I'm not going to label. Well, maybe I will. I've got one. Box that one off. Sure what that symbol thinks it is. There's not a -1. X equals -1 here. Then we might as well go ahead and put x equals 1 on this line. Then there's a line where y equals 1/4. I'm sorry, where y equals 1. And the line where x equals -1 and y equals 1 matches this point. X is -1, y is 1. And here, x is 1 and y is 1. So we have the points -1, 1 here. And 1, 1 here. Now we've got 2 more points. But you can see that when we connect these graphs with a smooth curve, it's going to do something like this, right? And have a parabolic shape. Okay, so we go to x equals 1/4. That's y equals 1/4. And I'll label it up here. X equals 1/2. And where those lines meet, we have the point. Whose coordinates are 1/2, 1/2 and 1/4. And over here, without going into the detail, we have the point -1/2 and 1/4. Okay. And if we sketch a curve. Here these points. We got a parabola. Call it a parabola. If you do it carefully, you get a nice parabolic shape. It's symmetric around the y-axis because what you get for a positive x, the y value you get for positive value of x is the same as the y value you get for the negative of that x. Okay, so this matches this. Okay, this matches this, this matches this. You say that this graph is equal to its reflection. if this is a mirror and you're looking in the mirror, what you see on the other side of the mirror is this, okay? You're looking from this side. So it's just a mirror image. All right. Well, that's an example of a function. We got a question. So I can walk straight. We're going to get that. Okay, couple of things. Now, when you make the graph, I just noticed a couple of you had kind of sharp graph, came down here almost like a V. If you carefully plot this point, that V ain't going to hit it, right? So you want to plot these carefully so you get the correct shape, because there's another function that has like a V shape, which is the absolute value function, which is a really easy function. We're not going to talk about it yet. So try to plot these carefully when you're starting out. And notice what I did when I plotted. I put -2 here and 2 here, tried to put them at equal distances. That was still a little too far. I tend to do that. I think it's just the angle I'm looking at. But yeah, out here, let's see, that was a little too far, but still, you get a good graph. You're not going to be precise with a hand sketch graph. Okay. And we sketch graphs by hand. We don't use calculator. There are places in the course where calculators kind of show us what a graph would look like, but we're not too interested in that. We're interested in being able to construct the things. As you see. Okay. Now in the distance class, you might use the graphic calculator somewhere. Still, you're going to need to be able to construct these things in any of these classes. Again, I put -2 here and 2 here, and then I divide that interval in half to get -1. And then I divide this interval in half to get 1/2, right? I did the same thing here. I divided the interval from 0 to 4 in half to get 2. And the interval from 0 to 2 in half to get 1. Okay. And divide this interval in half to get the number halfway between 2 and 4, which I believe is 3. Okay. So there it is. Now you should be able to construct that graph. There are other functions, important functions. But let's take that as a start. Okay, so what you want to do on your paper, okay, we have this picture, and ask everybody to draw a similar picture. And this point is 4, 9. I just picked those numbers. Okay, and I ask you to estimate f of 0, f of -4, f of 12. Now, there's no reason you should be able to do that. But ask if anybody could. Well, then ask about f of 0. Well, I didn't. And we've got some answers, but we want to modify them. Okay. Now, what about f of -4? Okay. How are you going to get f of -4? Well, I'm going to say get that by sketching the line x equals -4. Okay, can you sketch the line x equals -4? And so the big point is, if this is x equals 4, then where's x equals -4? Well, if x is 4 at this point on the axis, and -4 is going to be over here, isn't it? Just like, I mean, here's 2, here's -2, right? Here's 1, here's -1. Equal distance on the other side of the axis. So x equals -4 would be here. Okay. And then what's the y value when x equals -4? Well, remember that when I graphed these points, I did a vertical line for like x equals -2 and a horizontal line for y equals 4, right? Okay. So if I do a horizontal line here, Okay, according to my graph, this horizontal line is a little bit higher than the horizontal line I have here. So this would be the line where y equals 9. On this line, I think maybe I use a little wavy equal sign. I say y is approximately equal to 10. Okay. It's a little higher. Now, the way you drew it, maybe it isn't, because the way I drew the graph, it's going to be pretty close. Maybe you thought it was the same height. That's fine. Okay. I chose to draw it a little higher. This will show it doesn't have to be the same. It could be. Could be. Matter of fact, if I'd have drawn this line should be over this way. Let's tilt it a little bit that way. And if I did that, I might come out with something that's right on 9. Okay, so now we want to do it up with 12. Okay. Now, what does this mean? Okay, so what we did for f of -4 is we sketched the line x equals -4, and we found y, right? So we get f of -4 was approximately 9. Approximately 10. Okay, what are we going to do for f of 12? Same thing. We're going to sketch a vertical line for x equals 12. And then we figure out what horizontal line we're on. Okay. Okay, so we want to sketch the line x equals 12, right? And we're going to label it. So we're sure for what we have. Notice I've labeled every line that I've drawn here. Okay, so we come out and label x equals 12. Now, from here to here is 4, right? Because this is where x equals 4. How far do we have to go to get x equals 12? If 4 is here, 12 is going to be out there a little ways, right? Matter of fact, 12 is 3 times as big as 4. So if we just do 1, 2, 3. I'm going to fudge a little bit. I'm going to say it's out. I don't think it's quite this far up. There's the line where x equals 12. So here's the point on the graph where x equals 12. And then we can do a horizontal line. And y equals what? Well, if this is 9, then what's this? Okay. Make you an estimate. I would say y equals 1 is pretty reasonable. For what I've got. Because this is a lot less than this, right? If this is 9, then this might be 1. Now you could do a number of things. You could say if this is where y equals 9, and y equals 8 is about here, isn't it? So you can say on the y scale, right here is 8. Divide that in half, you get 4. Divide that in half, you get 2. Divide that in half, you get 1. Okay? So you can put your own scale on the axis. So y equals 1 is a pretty good estimate. Now, Haley, you asked, how would you find an x value if you know the y value? Okay, well, that's the other important thing we do. If you want to find on this graph what x value gives you y equals 3, you draw the line for y equals 3 and see what x value is below it. Okay, And that's what I'm really wanting to get you to focus, what the points in this graph mean. Okay, so, yeah, we still got a little room on this graph. Okay, so. If y equals 5, what is x? Okay, to get the value of x when y equals 5, and where's my yellow stuff? That little tiny piece, I can handle it. Okay, where's y equals 5? Well, here's where y equals 8, here's where y equals 9, here's where y equals 10, right? We divided the interval from 0 to 8 in half, we got y equals 4 here. So y equals 5, well, we could actually scale the graph, divide things up. Say, okay, y equals 5. Maybe here. Right. Now. We ask, if y is 5, what is x? Okay. How many answers do you have? Show me with your fingers. Okay. More than one, right? Some are saying 2, some you're saying 3. I see 3. But that's okay. If you saw more than one, you saw what you needed to see. Okay. So here. I'll say you find where the graph. I'm not going to be able to read this. You find where the graph intersects the line y equals 5. And you mark those points. Point here, point here, and point here. Okay. Then you find the x values. Well, you come down here to find the x value. Here's one x value. Now, if this is x equals -4, that might be x equals -5 or -6. And this is x equals 4. I think pretty symmetric there. Looks like this is about maybe 6. Out here. Well, if this is a line where x equals 12, this might be where x equals 14. So. Again, if I make kind of wavy equal signs, it means it's an estimate. Okay. So x is approximately -6. Means we're not sure, but we're kind of sure it's close. And x here is about 6. And here, well, I'm going to get fancy on you. I'm going to say x is about 13.5. Now that happens. I estimated 13.5 because this thing's a little closer to x equals 12 than this was, or this was to be x equals 4 or x equals negative. So my conclusion. My estimate is x is about -6, or 6, or 13.5. 3 answers. And that comes, had a really good question. How do you find x when you know y? Okay. Now for the squaring function, well, it turns out you take the square root, but you don't know how to do that. Okay. And you're not going to know how to do that. You'll never know how to do that. Okay. The only way you can do square roots of most numbers is punch it into your calculator. Okay, because you got a square root button on your calculator. Now, the square root of, can you tell me what the square root of 25 is with your fingers? Because we still got the camera on, right? Yeah, it's 5. 5 times 5 is 25. What's the square root of 26? That's a little more than 5. You can estimate it. You can draw a graph of the squaring function and, put y equals 26 up here, project down to the x-axis and see about what it ought to be. Okay. You could interpolate. You could say, well, square root of 25 is 5. The square root of 36 is 6. From 25 to 36 is just a little more than 10. So maybe it's about 5.1. Whether you understand that or not, you can do that. Okay. And then if you know the shape of the graph, you can actually modify that interpolation. It's a skill you're probably not going to need. So we won't talk too much about that. Now, in a calculus class, we would. Okay. But if you understand what we're doing here in this course with these estimates, then when you get to doing those sorts of things in calculus with the algebra and everything, you know what you're doing instead of just imitating something you don't understand. Well, most of you are not going to get to that point in calculus. We're going to prepare everything we can. So the better you understand this, if you do end up in a calculus course, in like the engineering calculus course, as opposed to, well, in any calculus course, it should be very helpful to you. Okay. Now, there are right now 3 assignments due for Tuesday. I'm going to change that. I'm going to be 2. One of them is on functions. So this should help prepare you. You're going to find that Open Math has videos and stuff. Okay. And of course, there's a textbook. And if hard copy of the textbook is not particularly expensive, I kind of recommend everybody picks one up. I'm pretty sure it's the one that's used in your course because that's the book that Mr. Lockley said he's using. Okay. And which is why I'm using it. All right. But it's a good book. So it's nice to have a book you can refer to. And they're really inexpensive, aren't they? Yeah, don't say anything because I'm still on camera here. But and I think they're like $10 or something like that. It's not more than 20, 13. Yeah. Okay. So it's probably worth the expense, especially, you're natural aid will pay for it. Because I've got it down. I think I've got it down as required text. It's in your Open Math. You got it there. So if that works for you, fine. Read the text, watch the videos, whatever other support Open Math gives you, and see how well you can nail the assignment on function notation. Okay. And not everybody's going to nail it completely. Don't let Chegg do it for you. Do it honestly so I can see what you're having trouble with and we can address it, right? Okay. Remember, bottom line is pass this course, we pass pre-calculus. Pass this course, pass the tests. Chegg's not going to help you do either of those. Dig it out yourself. Okay. Okay, well, good. So there will be 2 assignments. The other one is on rules for exponents, which presumably you've seen and will refresh by doing the assignment. And I'm not going to go over it. I'll go over that in the MDE 60 class. That's Algebra 1. Okay. And if you need to see what's there, the videos from that class will be on your Canvas as well as on the other Canvas. Okay.